Comparing data. When comparing data using Boolean expressions, it's important to understand the nuances of certain data types. Let's examine some key situations. Comparing floating point values for equality, comparing characters, comparing strings, alphabetical order, comparing objects versus comparing object references. Comparing float values. You should rarely use the equality operator when comparing two floating point values, float or double. Two floating point values are equal only if their underlying binary representations match exactly. Computations often result in slight differences that may be irrelevant. In many situations, you might consider two floating point numbers to be close enough even if they aren't exactly equal. To determine the equality of two floats, use the following technique. So here in this if statement, they're taking the difference of float 1 and 2 and they're finding the absolute value of that difference. And then they're using a tolerance to see if it's less than that tolerance. So if your difference is less than that tolerance, then you're saying that it's essentially equal. If the difference between two floating point values is less than the tolerance, they are considered to be equal. The tolerance could be set to any appropriate level, such as 0.000001. So let's go ahead and do an example of this. So I created this program so I could demonstrate the best practices when comparing floating point values. So I import my scanner class, I instantiate a scanner object, and then I have two numbers. One is a float, one is a double. And then I ask the user to enter in a floating point value, and I store that floating point value into num1. I'm using nextFloat. And then I prompt for another floating point value, and I store the result into num2, and I use nextDouble, and then I output what their values are. I'm going to go ahead and compile and run this program. So I'm being prompted to enter in some data. So I'm going to enter 4.5, and for my other float, I'm going to enter 4.5, and here's my result. Now what I want to do is I want to compare these two floating point values to see if they're equal to each other. So I'm going to go ahead and set up some if statements to determine if the two numbers are equal, less than, or greater than. Okay, so here's my if statement. I'm checking for equality. I'm checking if num1 is equal to num2. If it is, then I'll output a statement. If it's not, then I'm going to check to see if num1 is greater than num2. If it is, I'm going to output a statement. And the last case would be if num1 is less than num2, and I'm going to output a statement for that. So I'm going to go ahead and compile and run this program. So I'm going to enter the same values, 4.5. And you can see when I enter 4.5, the two numbers are equal. So Java is basically saying that these two numbers that I've entered, they both have the same binary representation. But I'm going to go ahead and run this program again. This time I'm going to enter in a floating point value with a little more precision. I'm going to go ahead and enter in 4.123. So I'm entering 4.123 for both numbers. And this time it's telling me that 4.123 is greater than 4.123. Now that makes absolutely no sense, but one is considered to be a float, one is considered to be a double, so their underlying binary representation is different in this case. So as I added more precision, their underlying binary representations changed. So now Java thinks that these numbers are not equal to each other. But these numbers are equal to each other, right? We can look at them and we can tell that these numbers are equal to each other. So you have to be very careful when you're dealing with floating point values because those fractions are being converted into binary numbers whenever this comparison is being done. So in this case, it's always good to use a tolerance like they did in the lecture. So I'm going to go ahead and set that up. All right, so I made some code changes. I made a tolerance, and I'm setting my tolerance to 1/1000th. So as long as the numbers are within 1/1000th of each other, then I'm going to consider them to be equal to each other. And I use what they did in the book, where you're taking the difference between num1 and num2, and you're finding the absolute value, and you're making sure the difference is less than the tolerance, and the tolerance is 1/1000th. So I'm going to go ahead and compile and run this program, and let's go ahead and test and see how this works. So I'm going to enter in my same test data. I'm going to enter in 4.5 for both numbers, and you can see those two numbers are equal to each other. Now I'm going to enter in 4.123, and you can see those two numbers are equal to each other. So now I entered 4.001 and 4.002. And now the numbers are not equal to each other because my tolerance is 1/1000th. But if I enter in values where the difference between the two is less than 1/1000th, then these numbers will be equal. And there you go. So we're using a tolerance to make our numbers effectively equal to each other as long as they're within a specific tolerance of each other. Comparing characters. As we discussed, Java character data is based on the Unicode character set. Unicode establishes a particular numeric value for each character and therefore an ordering. We can use relational operators on our character data based on this ordering. For example, the character plus is less than the character J because it comes before it in the Unicode character set. Appendix C provides an overview of the Unicode character set. In Unicode, the digit characters 0 through 9 are contiguous and in order. Likewise, the uppercase letters A through Z and the lowercase letters A through Z are contiguous and in order. But it's important to note that the lowercase letters have a higher value than the uppercase letters. So in your book, here's Appendix C. It's giving you all the different characters and the value that they hold in the Unicode character set. Now, this is not all the characters in the Unicode character set. This is just a portion of them. So the space is at 32, exclamation is at 33, and you have all these characters. They all have values. So if I were to compare the square bracket with the explanation mark would be less than the left square bracket. Okay, so whenever you compare characters, it's going to use the value inside of the Unicode character set. So let's test this with a programming example. All right, so I typed up this programming example and I went ahead and just created it, and we can just test it really quick. So the way this works is I'm using my scanner class. I instantiated a scanner object. I have two variables to hold characters, and then I'm asking the user to enter in a char, and I'm capturing that char by using the char at on next line. So I'm grabbing the very first character, and I'm doing the same thing for another character. And then I print out the two characters. Then I do a comparison. I check to see if the two characters are equal to each other. If they're not equal to each other, I check to see if char1 is greater than char2. And if that's not the case, then the last thing is char1 is less than char2. So I'm going to go ahead and compile and run this program, and let's test some of these values. Okay, so the first thing I want to test is the exclamation mark. And I want to compare that to the left square bracket. And here's my result. The exclamation mark is less than the square bracket. Now, the next thing I want to test is comparing a capital letter to a lowercase letter. So I'm comparing capital M to lowercase m, and here's my result. Capital M is less than lowercase m. And if I hop back to the book in Appendix C, you can see that capital M carries a value of 77, while lowercase m will carry a value of 109. Comparing strings. Remember that in Java, a character string is an object. The equals method can be called with strings to determine if the two strings contain exactly the same characters in the same order. The equals method returns a Boolean result. So they're using the equals method inside of the if statement's conditional. And if it's true, then they print out this statement. We cannot use relational operators when comparing strings. So keep that in mind. We can't use the greater than or the less than or greater than equals to or less than equals to. The string class contains the compare to method for determining if one string comes before another. A call to the string variable compare to, and then you pass in the string that you want to compare to. The result of this is going to return a numeric value. So it returns a 0 if name1 and name2 are equal. Returns a negative value if name1 is less than name2. Returns a positive value if name1 is greater than name2. Because comparing characters and strings is based on a character set, it's called lexographic ordering. So here they're calling compare to, and they're storing the result into an integer, and they're checking to see if the integer is less than 0. If the integer is less than 0, then name1 comes first. If it's not less than 0, then they're checking to see if result is equal to 0. If it is, then the two are the same. If it's not, then name2 comes first. Lexographic ordering. Lexographic ordering is not strictly alphabetical when uppercase and lowercase characters are mixed. For example, the string great comes before the string fantastic because all the uppercase characters come before all of the lowercase characters in Unicode. Also, short strings come before long strings with the same prefix lexicographically. Therefore, book comes before bookcase. So let's go ahead and test this. Okay, so I created this program so that we can test and compare strings. Now I went ahead and just copied what I did for the character data compare, but a string is an object, so this is actually not going to work correctly. So I'm doing the same thing. I have a scanner class. I have two variables for strings. I prompt the user to enter in a word, and then I prompt the user to enter in another word. I print out what the two words are, and then I'm using the equality operator to check for equality. Now remember, a string is the object, so the correct way of doing this is either using the equals method or the compare to method. If they are equal to each other, then I'm printing out this value here, and then I check to see if string 1 is greater than string 2 by using the relational operator. Now remember, the book said that we cannot use the relational operator when comparing strings, so I'm going to go ahead and compile, and we can see what error we get when we try to use the relational operator with strings. So when I try to compile, this is what I got. So Java is basically just telling me you cannot use these relational operators, so I'm going to go ahead and remove this. I'm comparing two strings by using an equality operator. So I'm going to enter in a word, I'm going to put in Mike, and the next word is going to be Mike. And then my output says you entered Mike and Mike. Now because this statement did not print out, that means that these two strings are not equal to each other. Now whenever you use the equality operator on an object, you're actually checking to see if the two object reference variables are pointing to the same object in memory. So if I wanted this to actually be equal to each other, then what I have to do is set string 2 equal to string 1. So now I have string 2 is equal to string 1. So that means string 2 object reference variable is pointing to the same place that string 1 object reference variable is pointing to. So now when I compile and run, these will be equal. So I'm going to enter in Mike. Now it doesn't even matter what I enter in for the next string, because after I enter in this data, I'm basically going to set string 2 object reference variable equal to whatever string 1 is pointing to. So I'm just going to type in a bunch of characters, press enter, and you can see I'm getting the output Mike and Mike are equal. Now, the only reason why Mike and Mike are equal is because I'm setting where string 2 object reference variable is pointing to. So technically, these two string objects that were created up here are not equal to each other. They're different. They're two different objects in memory. But in order to fool this condition here, I had to set string 2 equal to string 1. Now, this is not the behavior that we want when we're comparing strings. If you really wanted to compare strings, then we need to use the equals method or the compare to method. So I'm going to go ahead and set that up. All right, so I went ahead and set up some if statements using the equals method and the compare to method. So in my first condition, I'm checking to see if the two strings are equal to each other by using equals. This method is going to return a Boolean value, so either true or false. So I have two states here. I'm either equal or not equal, so I'm just printing out using the equals method, string 1 and string 2 are equal, or string 1 and string 2 are not equal. Then down here, I'm using the compare to method. The compare to method is going to give me a numeric result. If that numeric result is equal to 0, then that means that these two strings are equal to each other. But if I get a negative value from my compare, that means that string 1 is less than string 2. So whenever you get a negative value, whatever object you're invoking the compare to method on is the one that's going to be less than. If you're to get a positive value, that means string 1 will be greater than whatever it is you're comparing it to. So I created these output statements, so let's go ahead and compile and run this program. So I'm going to test two words that are equal to each other, and here are my results for using the equals method and using the compare to method. This time I'm going to test two words that are not equal to each other. Because I'm using a capital M, these two words are not considered to be equal. And when I use the equals method, I'm saying that they're not equal. When I'm using the compare to method, I'm saying that the lowercase version of Mike is greater than the uppercase version of Mike. So if I wanted to ignore case when I'm doing my comparisons, I can use the method equals ignore case and the method compare to ignore case. So I'm going to go ahead and change these methods. So I changed my methods to use the ignore case versions. So I'm going to go ahead and compile and run this program. So this time when I enter in Mike with the uppercase M, these should be equal, and they are.